Hello everyone. In today's video, let us learn how to identify 2, 3, 4 terminal of SMD components. For ease of learning, the video is split into two parts. Part 1 will cover how to identify the two terminal SMD components, the resistor, capacitor, and find their values. The rest will be covered in part 2.
At the end of this video, you will be able to identify the 234 terminal of SMD components, decode the printed code letters and record the values of SMD components. Let us collect the tools and equipment required to do this practical. Trainees toolkit, LCR meter with props, magnifying lens, assorted 234 terminal SMD components, resistors, capacitors, transistors, ICs as required. Let us discuss SMD components. SMD components are much smaller than through-hole components, making them ideal for compact electronic devices where space is limited. Their small size also enables manufacturers to design sleeker and more lightweight products. SMD components are soldered directly onto the surface of the PCB using specialized soldering techniques such as reflow soldering or wave soldering. This eliminates the need for holes in the PCB, reducing manufacturing costs and simplifying the assembly process. There are various types of SMD components including resistors, capacitors, diodes, transistors, integrated circuits, and more. SMD components offer several advantages over through-hole components including higher component density, better electrical performance, and improved thermal characteristics. Identification of two-terminal SMD devices. The major two-terminal components of SMD devices are resistors, capacitors, inductors, diodes, and LEDs. Let us discuss SMD resistors. Position the magnifying lens over the SMD resistor you want to identify. SMD resistors typically have a rectangular shape with metallic areas on the narrow ends of the chip which allows soldering. SMD resistors typically have markings consisting of 3 or 4 digits. In 3-digit SMD resistors, the first 2 digits represent the significant digits of the resistance value and the third digit, if present, represent the multiplier. The first 2 digits are 47, indicating the significant digits of the resistance value. The third digit 3 represents the multiplier. In this case, it stands for 10 to the power of 3 or 1000. So the resistance value would be 47 into 10 to the power of 3, which is 47,000 ohms or 47 kilo ohms. In 3-digit 222 resistor, the first 2 digits 22 represent the significant digits of the resistance value. The third digit 2 represent the multiplier. The multiplier is represented in powers of 10. In this case, 2 represents 10 to the power of 2 or 100. Combining the significant digits and the multiplier, the resistance value can be calculated as 22 into 100, which equals 2200 ohms or 2.2 kilo ohms. In 4-digit 4702 resistor, the first 3 digits are 470, indicating the significant digits. The fourth digit 2 represent the multiplier. In this case, it stands for 10 to the power of 2 or 100. So the resistance value would be 470 into 100 is 47,000 ohms or 47 kilo ohm. The SMD resistor notation 2 or 2 follows a slightly different convention compared to the standard 3 or 4 digit code. Numeric value. The 2R2 notations represents a resistor value of 2.2 ohms. R as decimal point. In the 2R2 notations, the letter R acts as a decimal point, so 2R2 translates to 2.2 ohms. Numeric value. The R56 notation typically represents a resistor value of 0.56 ohms. R as decimal point. In the R56 notation, the letter R acts as a decimal point, so R56 translates to 0.56 ohms. SMD capacitors. SMD capacitors have metallized connections at their both ends. SMD capacitors typically have a rectangular or square shape with rounded edges. Types of SMD capacitors. SMD ceramic capacitors, SMD tantalum capacitors, SMD electrolyte capacitors. SMD ceramic capacitors 10 microfarad 25 volts. Ceramic multilayer chip capacitors are available with a very wide range of values from 0.47 picofarad to 1 farad. In 0805, the length is 2 mm and width is 1.25 mm. In 1206, the length is 3.2 mm and width is 1.6 mm. The value of SMD ceramic capacitors is determined by the colors even if they don't have any markings. SMD capacitors are classified as Class 1, Class 2 and Class 3. Class 1 ceramic capacitors are typically white in color and have values that are lower than 1 to 10 picofarads. Class 2 ceramic capacitors are usually in light brown color. Their values range from nanofarad to microfarad and they are suitable for higher capacitance applications. Class 3 ceramic capacitors can be identified by their black or dark brown color as shown. This group of ceramic capacitor dielectrics provides lower capacitance at higher voltage compared to Class 2 ceramic capacitors. Set the LCR meter in the capacitance mode in the appropriate range to measure the close value of the SMD ceramic capacitor based on its color. Measure the value of the SMD ceramic capacitor by placing LCR meter probes on both ends of the terminals. Tantalum capacitors are polarized components, meaning they have a specific orientation for correct operation. The polarized code at one side of the capacitor indicates positive terminal and the opposite side as negative terminal. SMD tantalum capacitors are typically constructed using a tantalum metal powder as the anode material, a tantalum pentoxide dielectric layer, and a conductive cathode layer. They are encapsulated in a molded epoxy or polymer casing, which provides protection and insulation. SMD tantalum capacitors are available in a wide range of capacitance values ranging from a few microfarads to hundreds of microfarads. The markings on SMD tantalum capacitors normally consist of 3 numbers. The first 2 form the significant figures and the third is the multiplier. Values are in picofarads. Therefore, the SMD tantalum capacitor shown has a value of 47 multiplied by 10 to the power of 5 picofarad, which works out to be 4.7 microfarad. SMD electrolyte capacitors typically consist of 2 aluminum foil electrodes separated by a layer of electrolyte soaked paper or polymer. SMD electrolyte capacitors are available in a wide range of capacitance values ranging from a few microfarads to several hundred or even thousands of microfarads. SMD electrolyte capacitors are polarized components, meaning they have a specific orientation for correct operation. The black mark serves as a visual indicator of the negative terminal of the capacitor. This ensures that the negative terminal is correctly connected to the negative pad on the PCB. Significantly, the opposite or other terminal is a positive one. Here, the capacitance value and operating voltage will be indicated at the top of the capacitor as shown.
In this video, we have discussed how to identify the 2-terminal SMD components, the resistor and the capacitor, and find their values. This concludes the part 1. See you in part 2.